Hey everyone, welcome to episode number 6 in your Bash tutorial series. This video we're going to talk about numbers and working with numbers inside of if statements. So pay attention, we're going to start off with a fresh file so we can follow along, and we're going to ask the user how much money they have. A little invasive, but sometimes you just got to ask, how much money do you have? Maybe a bank is asking a user, probably a little bit more formally than this, but this will do. And this is going to go in a variable called money. And I'm going to be a little bit more specific actually. How many dollars do you have? And we're going to echo that back just to make sure everything's going good. And say you have money dollars. So we'll run this, give it a test. How much dollars do you have? 5,000. You have $5,000. Now this is a perfect opportunity to introduce you to a challenge you might face. What if you wanted to prefix this with a dollar sign? You could imagine having $5,000 like so. Well, that is interesting because this is not going to work the way you would expect. So we'll try it out. We run this. How many dollars do you have? We'll say 9,000. And it says you have 32822 money. Interesting. It's quite insightful. So what is going on here? Well, when you echo two dollar signs, it's actually going to give the process ID. So 32830, and every time we run this, that number is going to change. This is a number that is just given anytime you run an application to identify that process. So these dollar signs are being interpreted. They're being replaced with a value. If you want to tell the computer, yo moron, don't change these dollar signs to some random number, instead just print a dollar sign, then all you have to do is prefix with a backslash. So what we could do is we could put a backslash here, and this will escape the dollar sign. This concept is known as an escape sequence, and there's a bunch of them out there. A similar example of when you might need to do something like this is if you need to print double quotes inside of double quotes. Hey there, she said. Well, in this situation, pretty much the same thing's going to happen where this second quote here is going to close the string and the program's not going to work. So to fix this, we need to prefix backslash here and a backslash here. Running it now and it should work. Hey there, she said. So that's another example, but that's not exactly the focus of this video, but just a little aside on escape sequences. What we can do now is we can condition on the value of money, and it's going to work just like the previous video. So we'll say if quotes $ money, and this $ here refers to the variable, not like a dollar amount, and then an equals here, then some value like 9,000. Then we will echo not bad. And then we'll end the if statement. So when we run this, how many dollars do you have? We put a value like 9,000. It says not bad. If we run it again and we put a different value like 5,000, we don't get that. So far, so good. And this is how you can compare exactly to a value. However, this is not the ideal way of working with money. You see, if I introduce a new comparison, such as greater than 9,000, when we run this now, if we put 9,005, it says not bad. But if we put 5, it still says not bad. This is very strange. And it's another one of those gotchas of Bash that you probably just want to start a list and keep track of because there's about 1,000 ways to die with Bash. So this comparison operator is not actually comparing anything. And what you would basically want to do is replace this with hyphen greater than GT. And now, if we put 5, we don't get echo not bad. And how many dollars do you have? Let's say 9,005. We do get not bad. So you can see it is working now. So this is one way of doing it, and there's a bunch of different operators that you can use. There's less than, there's greater than or equal, but this isn't really my favorite way of doing it. I prefer the operators we all know and love. So to do this, what we can do is we can actually replace these square brackets with parentheses. So it's going to look like this, and I'm going to use the greater than symbol here. So we will run this. How many dollars do you have? Say 9,005, it says not bad. And when we say 5, it doesn't give us that output. So here's how you can use comparison operators. So two parentheses. Now, you may also see 2 square brackets, and this is a standard capability inside of Bash, but again, when it comes to cross compatibility with other shells, this is not always accepted. So you can use single or double square brackets when you're using square brackets. For the numeric comparisons, well, you're going to want to use double parentheses. So that's how you check if it's greater than 9,000. If you want to check greater than or equal to, you just add an equal sign there. So now when you put the value 9,000, it evaluates as true, and anything above 9,000 as well. Now sometimes you will see less than or greater than operators with the square brackets, and this is actually doing something different. So let's take a look at that real quick. So I'm going to switch this over to a square bracket, and we're going to say greater than 9,000, and let's actually choose a different number here, like 7,000. And then it asks us for how much dollars we have, and we'll say something like 8, and it says not bad. If we say something like 5, it still says not bad. When we do this with double square brackets, we do get a different behavior. So run this again. How many dollars do you have? If we say 5, we don't get the output we expected. If we say 9,000, we do get the output we expected. However, if we went ahead and said something like 9, now we get not bad. Okay, I'm confused. What in the world is going on? Well, when you see the double square brackets or single square brackets with the escape here, this is actually comparing alphabetically. So in that situation, it looks at the very first character, consider these to be strings, 9 versus 7,000. 9 is greater than 7 when you're comparing alphabetically. 5 is less than 7. So the comparison operator when you are working with square brackets is actually comparing alphabetically. This is scary because you might be using the double square brackets, using a comparison operator like less than or greater than. You might not really be thinking about it, not realizing that it's actually comparing as if they were letters, sorting all the 7s together, all the 8s together, and all the 9s together. And you might test it out with 1 or 2 examples and get the result you expect, but there's actually a bug in your software where it's not going to compare the way you would actually expect. So watch out for that. If you're going to be comparing by quantity or like the size of the number, then you will want to use the double parentheses. If you're comparing alphabetically, then I would recommend to use the double square brackets. Here is a list of some of the other operators you might run across. So this is from tldp.org. So you got these for when you're using square brackets: equals, not equals, greater than or equal to, less than or equal to, less than or equal to, greater than or equal to, and then some string comparison stuff as well. And here is where we're talking about with ASCII alphabetical order. So hopefully this was helpful. Stay tuned for the next video where we're going to be talking about probably how to combine multiple if statements and use logical operators. Stay tuned for that. It's going to be pretty cool.